All right. So the question was here you have to calculate the time of flight. So how will you get the time of flight over here? So basically, for that, you'll be using s is equals to ut plus half at square. Considering the
Yeah.
vertical dimension or the horizontal dimension,
Uh,
what are you considering?
I think I considered the vertical dimension.
Okay. So let's consider the vertical dimension. So for the entire journey, what do you think is the vertical displacement over here?
Minus 125.
Perfect. What is the initial vertical velocity?
25 meters per second.
That is 50 sine 60.
Yeah.
So is
No. Yeah, 43.3.
43.3. I'm writing this as capital T minus 5 t square. Do you agree?
Yeah.
Okay. So with that, we can write 5t square minus 43.3t minus 125 equals to 0. Right?
Yeah.
Then when you solve this quadratic equation, you'll get the value of t. And this t is not equal to 5 seconds. So can you tell me?
Yeah.
Yeah. So can you tell me what is the value of this t now?
Okay. I x minus 43.3 minus 125.
Mhm.
Okay, it's a very big equation. I'm just
Come on. This is
0. Okay, it's a quite big equation.
no, it's not a big equation. Come on. All right. See, this thing is this is what is it? 5t square. What is it?
Minus 43.
5 minus 43.3 and minus 125, right?
Yeah.
So this is 5. Then this is minus 43.3. Yeah. And then this is minus 125, right? Minus
Yeah.
125. Yeah. So so you get these two. So 10.944, that is something that we'll be taking. Yeah.
Yeah.
10.944. So let's say this is 10.94. So t is equals to
Yeah.
10.94 seconds. This is the answer that we'll be getting. It's damn simple, isn't it?
Yeah.
Yeah. All right. So we got the time. Now, how will you get the value of x? X is equals
The Vx.
that is the
The
horizontal
Vx.
range. No, the
Oh,
horizontal
the
range.
horizontal range. Horizontal range is the
Mhm.
horizontal speed
That is, what is it?
times cosine of the angle.
50 cosine 60, right? So that is
No, 50 is the combined one, right? So
yeah.
25
So
percent.
no, the horizontal speed, that is ux, will be equals to u cos theta, but u is 50. So this is 50 cos 60. So that is coming out to be 25. Yeah.
Okay, yeah. Oh, okay. I see. I see.
Okay. So this has to be 25. I want you to
Yeah.
revise before every class. I want you to revise the previous class with the video. Okay, with the recorded lesson. Okay.
Yeah.
Yeah. So x will be coming out to be 25 multiplied by what I should multiply this with?
10.94.
Yeah, so 10.94. So that will be giving you the final answer in meters. So what is that?
Yeah. 273.5.
200
73.5.
meters. Yeah. Wait a
Yeah.
second. Okay. No problem. So we got the x also. Now, how will you determine the value of Vy? How?
Okay, so we know acceleration minus 10 and time is equal to 10.94.
Time is equal to
And
10.94. Yes.
initial speed in the vertical is what
43.3.
did we get? 43.3.
Yes.
So
Mm-hmm.
we can use v is equal to u plus 80,
Perfect.
or vy
So
is equal to u plus 80.
yeah, so Vy is equals to Uy, that is 43.3 plus 80, that is minus 10 times 10.94. Yeah.
Yeah.
So what do you think? What is the answer?
Minus 109 times 43.3 is, or plus 43.3 actually.
Mm-hmm.
And minus 43.3 is minus 66.1.
Minus
66.1.
66.1 meter per second. Now,
Yeah.
you know Vy. Okay. So can you get the value of
Yeah.
V? Can you get the value of V?
Oh, the value of V.
Mm-hmm.
Okay, so V is equal to V Y. One moment.
Vx
Yeah.
square plus
So
Vy square. What is Vx, by the
yeah.
way?
So yeah, V Y is equal to V sine theta. So minus 66.1 is equal to V sine theta.
But do you know theta?
No, we don't, not yet, no.
Yeah. So do you know Vx, by the way?
Yeah, Vx is the same always because the horizontal is constant.
Correct. So using Vx and Vy, you can get V from this formula. That V is equals to under root Vx square plus Vy square. Yeah.
Yeah.
So what is it?
25 squared plus 43.3
Why
squared.
43? Wait a second. Why 43.3? At this
All right,
particular
minus
point,
66.
yeah, exactly.
So minus 66.142. So 625 plus is minus 3,744. And square root of that is,
Hmm.
okay, it's a negative number. It shouldn't give me a negative.
It shouldn't be negative.
Okay, yeah, it should not. I don't know what it's giving me. It's a square. How do I get a negative on a square number?
See, the thing is, so this will be equal to, okay, this
A
will,
positive, yeah.
yeah, you'll be taking the positive value. So this will be equal to 25 square plus bracket negative 66.1 the whole square. So
Yeah, I
when you
get
do this thing,
70.66.
625 plus whatever this value, that also will be positive. Ultimately, you'll be getting the positive answer. What are you getting?
Yeah, 70.66 meters per second. Or
70.66
67.
meter. Yeah. So we got V to be equal to, this V is equal to 70.66 meter per second. Now you can get
Yeah,
theta. Now you can get theta easily. So how will you get
yeah.
theta?
So Vy is minus 66.1 is equal to 70.66.
You should best do
Uh,
this thing, that theta is the tan inverse of Vy over Vx. Okay. So you can
okay.
directly do this. Yeah. Theta is equals to tan inverse opposite upon adjacent.
Minus 66.1 divided by 70.
Vx, that is 20. You're doing tan inverse.
Vx. Yeah, okay. 25. And delete and delete.
Yeah.
Minus 69.3.
Minus 69.3 degree. That means this shows that like you're basically taking in this particular direction like this. So
Yeah,
this theta is equals to minus 69.3 degree. You got it? Yeah.
Yeah.
So is this whole thing clear to you?
Yeah.
Perfect. So let's go ahead. All right, so we are done with the projectile motion. I hope you found projectile motion easy. Yeah.
Yeah.
Okay. See, the thing is, the thing that you should keep in mind that like never treat them together. Treat them separately. Like
Yeah.
horizontal motion separately, vertical motion separately. You'll always get the right answer. Okay. You got it
Yeah.
right. Yeah.
Yes.
Okay. So now we are going ahead, and now what we are going to cover is the force. Okay. Force and the free body diagram. Okay. All right. So all right. So talking about the force. First of all, what? How will you define a force? How will you define a force?
Mass times acceleration.
That's the definitely it is a mathematical definition. I never expect the mathematical definition. I want actual definition of the physical definition. So force is something which can produce an acceleration in an object. Okay, that's how you can define
Okay.
force. What is force? Force is something which can produce acceleration in an object. Like when you are applying, suppose some kind of force on this particular object, which is having mass m, going with velocity u, let's say. Okay. So when you apply the force, what will happen that this object will start now moving with some different velocity. Okay. You can in fact
Yeah.
like change the direction also. Like this can start going in this particular direction, v dash, let's say. So in both the cases, it is changing the velocity, even if the magnitude of this velocity is same as this one. But since it has changed the direction, so definitely there is an acceleration. Okay, so force is something which can produce an acceleration in an object. Okay, that is
Okay.
either increase in velocity, decrease in velocity, or the change in the direction of the motion. Okay, all of
Yeah.
these can be done by the force. Okay, and all these things are considered to be the accelerated motion. So force is something that can produce acceleration in an object. Acceleration
Okay.
in an object. Yeah. All right. So that's how we define force. Sure. Let's go ahead. So the thing is, you will be coming across different types of forces, and to understand their effect, you will be you have to know the three laws of motion. To understand the effect of force, you should know all the three laws of motion. Those were proposed by Newton.
Okay.
Okay. So what are the Newton's three laws of motion? Let's understand them. So Newton's first law. So what is the Newton's first law? I call it law of laziness. Why? Because this means that you don't come out of the bed until you are kicked by mother. Okay.
Yeah.
All right. So the point is you don't come out of the bed until you are kicked by ma. Okay. So
Yeah.
if an object is at rest, it will remain at rest. If you're sleeping, you continue sleeping. Okay.
Yeah.
So if an object is at rest, if an object is at rest, it will continue, it will remain at rest, remain at rest. Or, or if moving with uniform velocity, if moving with uniform velocity, it will continue the same way. It will continue moving the same way. It will continue moving the same way. Okay. Until unless an external unbalanced force is applied on it. Yeah.
Yeah.
So this is the first law. That is the Newton's first law. This basically explains the resistance of an object to change its state. Okay, it is basically, what is it explaining? It is explaining the, it explains the, it explains the resistance of an object, resistance of an object from changing its state, from changing its state of rest or state of motion, state of
Yeah.
rest or state of motion. Yeah. So, so this is the this is very important thing, that like if an object is at rest, it will remain at rest. If it is moving, it will continue the same way until unless an external unbalanced force is applied on it. Okay. See, the thing is, I'm using the term external force, unbalanced force. Like you're sitting in the car. Let's say you are sitting in the car. So you are the part of the car now. Okay. If you're
Yeah.
sitting inside the car, you're the part of the car. If you're just pushing the car, if you're just pushing the car, pulling the car, do you think that like being on the flat road, do you think that the car can be moved ahead or moved backward?
No, because it's quite heavy.
Obviously, even if you are sitting in a very light car, let's say, like suppose if you're sitting in a box and you're sitting inside a carton, let's say, if you
Yeah.
try to move yourself forward or backward, so can it be done by just pushing the box, pushing the walls of the box, or like doing anything
No,
like that?
not possible.
Nothing, right? You can't do anything. So that means like internal force is not going to move it. Okay. So
No.
so, but if you apply, if there is a guy from outside and he is pushing the carton, he is pushing the box, or he's pushing the car, definitely it can be moved. You're getting it?
Yeah.
Yeah. So basically, there has to be an external force, an unbalanced force. What do you understand with the unbalanced force? Like here you are in the box, you're sitting here inside the box. So even if you are pulling whatever you are doing, if the road is flat, you're not able to move yourself. But like if there is a guy who is outside, he's applying some kind of force, definitely it can be moved further because of the external force. Now if suppose there is a force in this particular direction, okay, and there is
Okay.
a force in this particular direction, okay, they both cancel each other. So in this case there will be no movement. Yeah,
Yeah.
because this is
It's
the balanced
balanced.
force. Yeah, this is the unbalanced and external force. This has to be unbalanced and external force only. Okay, this entire property, this entire first law is actually the property of an object, and this property is known as inertia. Okay, so this is also known as inertia. Now this inertia is of two types. Oh, sorry, three types. One is the inertia of rest, inertia of rest. Another one is the inertia of motion, inertia of motion. And the third one is the inertia of direction. Okay, like suppose if you're sitting in the car,
Yeah.
you're sitting in the car. Okay, your initial position is like this. Yeah, and all of a sudden, the car starts moving forward. You are not driving the car, by the way. Okay, you're just sitting it. So all of a sudden, the car starts moving. So from rest, if it is set into the motion, what do you observe? That you get a backward jerk. Yeah, isn't it?
Yeah.
Why do you get a backward jerk? Because when you were sitting in the car, okay, the entire body was at rest with the car. Okay.
Yeah.
Now, as soon as the car started moving forward, so the portion of your body which is in direct contact with the car started moving with the car. But the upper
Yeah.
portion, which is not in the direct contact with the car, okay, that was sent backward. Why? Because the upper body is still resisting from moving forward, and that's why you're getting a backward jerk. This is known as the inertia of rest. Okay.
Okay.
There is another thing, that is inertia of motion. This inertia of motion is observed when the car is already moving. The car is already moving. You are in a good posture, okay, already moving, and all of a sudden it comes to rest. Then what happens? You get a forward jerk.
you go as,
Yeah,
yeah,
you get a forward jerk. Okay, why is it so? Because the upper portion of the body, which is not in direct contact with the car, doesn't stop with the car because it is having the state of motion, and it resists to come to the rest, okay, with the car. And that's why it
yeah,
is still moving when the car is stopped. The car is stopped and you're still moving, and that's why you get a
yeah, I
forward jerk.
see. Yeah,
You're getting right. An exact same thing can be understood with the inertia of direction. And if you're taking a sharp turn, okay, when you're taking a sharp turn, okay, so you are having a tendency of going in this particular direction, okay, but
yeah,
the car started moving in this direction. So you get, when it is going in this particular direction, the car is going in this direction, your body is being thrown off in this direction. You're getting it? Why?
yeah,
Because you are having a tendency of moving in this direction. So you resist to go in the in a different direction. That is the direction of the car. You're getting, and that's why you get a jerk in the opposite direction. This is known as the inertia of direction. So all
yeah,
these are basically the property because of which an object is resisting the change. You got it right?
yeah, yeah.
So do you have any problem in understanding this part?
No, I fully understand it.
Hmm. All right. There's a famous experiment for of inertia, that like you take the glass, okay, and on this glass you put the cardboard. You put the cardboard, and then on the cardboard you put the coin. You put the coin. So when you basically uh, when you try to hit it, okay, when you try to hit the card, when you strike the card, okay, so when you're striking the card, the coin the coin is having the tendency of being at rest, and that's why the
Yeah,
card moves off, but the coin remain at that same position, and then ultimately the coin falls into the glass when the card is away. You getting it? Yeah.
yeah,
Okay, so basically this is the inertia of rest. Here, this is demonstrating the inertia of rest of the coin. You getting it? When the card is moved, the coin has a tendency of being at rest, and that's why it remains in that position, and then it falls into the glass. You got it right? Yeah.
yeah,
All right. So this is a simple demonstration of the inertia of rest. Okay. The next thing that we have is the second law. So far we did the first law, which actually explains the effect of the force, that what the force can actually do. The force can actually bring the change in the state of object. That is, like, if it is in the state of rest, it can be brought into the state of motion. If it is in the state of motion, it can be brought into the state of rest. And also, if it is moving in a specific direction, it can change the direction. Okay, so this first law is actually defining